Now then, crew, and welcome back to the Andy Mechanic YouTube channel. I know it's been a while since the last video. However, I'm busy building a trailer. This actually is a pod to go on the back of the trailer for all the tools and bits and pieces for an up and coming adventure trip that Mrs. Mechanic's doing. But in the process of sort of working out the best options for the trailer chassis design, it's opened up. Well, I started to realise that some of the information that I was gathering up and contemplating different designs, a suspension system, braking system, hitch arrangements, all that kind of stuff would be really, really useful to lots of people around the world. A couple of years ago, I made a video on how to make a new trailer axle. You know, often they need to be replaced due to corrosion or whatever. And that video has done extremely well. Lots of people obviously build their own trailers around the world. So again, this video should be really helpful to you if you're planning to build your own trailer. Or potentially if you're looking at buying a particular trailer, the pros and cons of different design types and suspension and so on that really you need to be aware of, because each design has its, you know, its own features for particular kind of usage, whether it's off-road, heavy towing, handling, maintenance even, you know, and of course parts availability is something else to take into account. So I thought we'd start off with showing you very quickly the pod that I've made. It's not quite finished, but it's nearly finished, and then we'll go across and we'll start to discuss probably hitches first of all, different kinds of hitches that you can get and what they're good for and what they're not quite so good for, and of course, you know, the cheaper options and the expensive options as well. So without further ado, I'm going to grab the camera and take you around what I've built as this particular pod. Now, unlikely that you'll ever build one of these things yourself, but it might give you an idea of the kind of stuff that we do here in the Andy Mechanic workshop when we put our fabrication hat on. Here we go. Used.
You don't paint something without warping.
Honestly. So this is the pod. This is going to be basically the middle and the rear of the trailer. At the front part, which is where this X-frame is, that's actually been put in there because off-road trailers can roll over, and that will act a bit like a roll cage because, you know, we don't want to cause any damage or lose the integrity or the shape of the pod. That'll be the first thing to hit the ground. In the front will be a bike rack, and of course the hitch will be somewhere down here. And in this video I'm going to discuss with you the final design and how the design changed for the trailer based on change of equipment, mainly the suspension system, to be honest. But as you can see, it's all gone pretty well. It's 40 by 40 mil box with a 4 mil wall. Everything's all made of that, and the main reason why I chose that for this particular part of the trailer is because I had it already in stock. And it's sort of okay. It's probably a little bit over the top for this particular job, but you know, it sort of works. And it came out very well. That was 2 days work to this stage, by the way. And there were 2 long days. But we got there in the end. This is the rear of the trailer. And you can see I've put these sort of chamfers in here, these 45-degree angle bits, mainly for styling. I didn't want it to just look like a box on the back of the trailer, but also if it does decide to roll over, it gives it sort of a nice flat surface to rest against as opposed to a pointy bit if it was 90 degrees. Now, one last feature, with it being an off-road trailer, with this being the rear, just down there, look, is departure angles. Normally a trailer would finish with a right angle at the end, a box trailer, and of course potentially that can drag on the ground if you're going through gullies and stuff, so it's always a good idea to put a bit of a kick in there. The only downside of that is the door at the rear, which will fit inside this area here. It doesn't go all the way to the floor level. As you can see, that's the floor down there, look. So anything that goes in the trailer will have to be put down and in. Obviously it's a bit higher to lift stuff in, like toolboxes and things, but it's a small price to pay to make sure your trailer doesn't ground out. Right, enough of the pod. That's all you get to see on that for now. There will be further videos later on covering more on that. let's get back to trailer design. So I'm going to jump right to the end of the design, and the design of this particular trailer, with it being an off-road trailer, it's going to be used in an off-road environment, going through rivers and gullies and down dirt tracks and that kind of stuff. I was very conscious about the hitch arrangement on the trailer. A normal 50mm or 1 7/8 ball hitch, which is traditional for towing trailers behind cars and four-wheel drives, doesn't provide that much angular movement. Imagine the vehicle, is going down a gully. It's got the trailer on the back, so this is the vehicle here. Look, this is the trailer. It goes down a gully, and then the towing vehicle then starts to climb back out of the gully. The trailer's behind it, and you end up with this really acute angle. And that's the biggest problem for a ball hitch, as it runs out of movement and it starts to stress the tow bar, the towing hitch, and of course the trailer's own A-frame as well, or drawbar, whatever the design is. And it becomes a problem, because if it breaks and in the middle of nowhere, how are you going to get your trailer out of there? Plus you might damage your vehicle as well, so your car. So bit of an issue. So I went online and I started to do some research on various trailer hitches. Let me show you what I found. So this is a 3.5 ton coupling made by a company called ARK, or ARK. They're based in Australia, and there's quite a few hitches out there which are very similar to this design. You can see it's got an additional swivel at the front. This one connects to a standard 50mm ball hitch, so you don't need to make any modifications whatsoever to your towing vehicle. It just clips on. However, one of the problems, or one of the issues that I was concerned about, is how am I going to provide braking to the trailer. And being a 3.5 ton hitch, the trailer has to be braked if it's a 3.5 ton trailer. In actual fact, anything behind the little Jimny that we're towing with that's over 500 kgs trailer weight, that's gross weight, needs to have brakes. And when the hitch when you set off forwards, the hitch extends, and when you brake, it pushes this push rod through the coupling, and that big nut there actuates your hydraulic brakes. And you've got to bolt onto that a bracket, and it took me a while to get this confirmed. The 4 bolt mounts there, is a standard fitment on trailers, a 4-bolt mount. And I went onto Trojan website. They're based here in New Zealand, and I looked up hitch components, and this one here is the part that you need to fit. It mounts via this bracket here mounts via the last 2 bolts, the rear 2 bolts on the hitch, same bolts, and the push rod, which is this bit just down here, that's adjustable. Basically, when that bolt gets pushed through the hitch when you brake with the car, it pushes that back, and then it pushes forward onto a master cylinder. So we'll just go back. Let's go back one. There we go. Look, there's another one that's, I think, got the actual master. There we are. Look, it's got the master cylinder on it. There you go. So you can buy the whole lot in one piece. There's your master cylinder, and as that gets pushed back, this is the rear of the trailer, this is the front of the trailer. As that gets pushed back, it obviously pivots here, and it actuates the master cylinder that provides your hydraulic brakes. Plus, you've got a hydraulic braked handbrake. Basically, there's a mechanical ratchet here, a locking device where you can apply the brake manually and lock down the bar to hold the brakes on. It's not ideal because it's reliant on the hydraulic system to hold the handbrake, and if there was a minor leak, then it would lose pressure over time and the trailer would roll off the handbrake. But it would have done the trick for what we wanted. So once I made contact with Trojan to discuss that bolt-on master cylinder bracket handbrake device bit to go with the ARK coupling, which I'd already reserved at Burnscote on the North Shore in Auckland. That was about $400, I think, to purchase that, which I thought was okay. It was a bit pricey for what I wanted, but it was a very well-made piece of kit. Once they confirmed that master cylinder and stuff was going to work, I was really very much geared up for going for hydraulic brakes, disc brakes with calipers, using that master cylinder and using the ARK hitch. It was all sort of coming together. But one thing I was still trying to sort out was the suspension on the trailer. And originally, I had looked at independent suspension using indispension units, which are basically a rubberized, 4 sort of triangular pieces of rubberized block around a solid square rotating axle inside a piece of box section. So basically the rubber just gets squashed as the suspension is compressed, and that's basically it. Pretty low maintenance, but not really ideal for off-road environment. There's not that much travel on the suspension, and also extremely expensive as it turned out. So I was asking them, look, you know, I'm going to have to go for the traditional leaf springs. So I'm going to need a leaf spring kit, 1.25 ton total trailer weight. So that's split over the 2 leaf springs, and a hub and stub kit. So I could make my own axle, just like in the previous video that I made, make up my own axle, exactly the right width for this new trailer, use the stub axles that they supply and the hubs that they supply. But I said I need the hubs to have a PCD of 5.5 inches, the same PCD as the wheels on the 2022 Suzuki Jimny, Generation 4, I believe it's called. And he says, ooh, we don't make hubs with that stub pattern. So we hit a wall. Big problem. He says, look, maybe we can get some drilled, but that's a very large PCD, so you're going to have to go for the super heavy duty hubs that we normally use for 3.5 ton trailers. And again, very expensive. The price, the cost of this whole project was starting to go through the roof. And he said, have you not looked at the, what's it called? It's called, bear with me, hang on, bear with me. I'm back. Okay. He said, have you heard of Cruisemaster? And I said, I haven't. I have no idea what Cruisemaster is. He said, well, go and watch the video. And they had a little TV playing, flat screen TV playing a video of the Cruisemaster suspension. And we're going to have a quick look on their website shortly at a video that they have showing it in action. The Cruisemaster suspension is independent, so it ticks the independent suspension box. And what that does with independent suspension is it allows for additional clearance under the trailer. You don't have this beam axle going all the way across from one side to the other that can catch on rocks and stuff. A bit like a differential, you know, in a back axle of a 4-wheel drive with a live axle. You know, there's just nothing there. And that's the picture. There, look, you see. So it's a CRS2, which is the country road suspension, and it's the 2nd generation of that. And it looks extremely good. It also looks very, very expensive. But it's coil sprung, and coil springs are far better in an off-road environment. They react much quicker to undulations on the terrain, keeping the tyre in contact with the ground. So that was a major plus. The kit also comes with twin shock absorbers either side to control the oscillations of that spring, so you don't get that sort of bounce when you go over a rock. And with a leaf spring, especially light trailers, they tend to bounce right up in the air, and then they come down, then they bounce again, because there's not a lot of damping on a leaf spring, which is bad. So that solves that problem as well. And it's a trailing arm system, much like a motorcycle rear swing arm. You know, it's far better suited to reacting to approaching bumps and for the tyre to ride over the bump. It's sort of more of a natural design rather than a wishbone, you know, like on a quad bike, which basically, you know, moves up and down across the vehicle, you know, which there's still a loading, and that's what wears bushes and stuff, because it's always trying to kick the wheel backwards, whereas, you know, when it hits a rock, whereas with the trailing arm, you know, it's a lot stronger, it's a lot more resilient to movement of that wheel forwards and backwards, and basically that force is immediately transferred to pushing the suspension arm up, the trailing arm upwards, and allowing the tyre to roll over the bump. So it flows a lot better. If you look at comp safari trucks and stuff, they all have trailing arm suspension, and that's for that very reason. However, with it being independent suspension, and there's no beam axle going across, they operate completely independently, there's a lot more stress applied to the chassis of the trailer. So let's go across now and take a look at the the Cruisemaster. Still getting my terms right here. It's all brand new to me. So have a look at the Cruisemaster suspension in more detail. I've got some really good engineering drawings that I've got off the internet showing you how to install. And part of the Cruisemaster suspension is that it runs electric brakes. And there's some real benefits to electric brakes in an off-road environment. We'll talk about that a bit later. Cruisemaster also make a very similar hitch to the ARK1, which is geared up for electric brakes. Basically, it's a full kit. It all works in harmony together. And of course, you can fit a handbrake, which is cable activated, a pull cable, as opposed to relying on a hydraulic pressure in a system. So cables are a lot more reliable. When they're on, the brakes stay on. There's no possibility really of them failing unless the cable snaps. So, other bench, let's look at some drawings. Here we go. So with the Cruisemaster rear suspension, the independent suspension, you can see that they're completely separate sort of modules. You've got the bracket that you weld onto the chassis of the trailer. The trailer front would be in this direction here. That's the front up there, look. And it's actually a very, very simple installation. You just got to make sure you get those lined up. Obviously, the trailer needs a very strong cross member to weld these two, and the cross member needs to be 100 millimeters tall by 50 millimeters wide. These box section, according to the drawings, are 50 millimeters by 50 millimeters. So the 100 by 50 drops into this little slot at the top for alignment, and then you weld it into place. And there's full instructions on how to do that supplied in this this fitment guide, installation guide. Now, the layout of the system, there's some pretty good information on here, and actually critical to the design. The pivot point for the trailing arm is here. That's a side-on view of the bracket, and I'm going to put this particular file, all these drawings, on a Google Drive, and I'll put a link in the description of this video, so you can bring them up yourself on your laptop, and you can see in a lot more detail these engineering drawings, which are actually really well done. The actual wheel center, the effective point of the axle, is now 312 millimeters backwards from the suspension arm pivot point, and that's a critical measurement because you need to know, very importantly, where the axle is going to sit on your trailer to do with hitch loading and the balance point of the trailer. And some trailers have the wheels a lot further back than others, and it all depends on what you want to do. In general, the further back the wheel is on the trailer, the longer the distance from the wheel, where I'm assuming it's a single axle trailer, from the front axle of the trailer to the hitch point, the longer that distance, the better the trailer tows. But there are loading factors that affect that as well. But also, the easier it is to reverse the trailer as well. The shorter that distance, the trailer gets quite flickable, when you're trying to reverse, and you've got to be really accurate with the steering. If it's a nice long distance, it makes reversing the trailer so much easier. That's why big trailers are actually easier to reverse than little tiny ones. It also gives you the measurement of where the shock mount needs to go onto the chassis side, and that's 324 millimeters rearwards from the back side of that 50 by 50 box, which is the pivot, the front mount for the trailing arm onto the chassis. So again, a critical point for when you're welding those on. Now, if we carry on, this is the chassis requirements, and as you can see, because these are independent suspension units, this cross member here is absolutely critical, because if I just draw on the drawings, basically when the wheel it hits a bump or the load applied to the suspension, that part of the chassis is going to want to go upwards like that, as is this side here, because of the load, and that chassis is going to want to bend up in the middle. So it's absolutely critical that it's super strong, and it goes all the way from one side to the side of the chassis, to spread that load across, and to keep these two suspension modules in alignment. The loading is quite immense, in all honesty, on an Indy suspension. With a leaf spring sprung vehicle, that loading is really taken up by the actual axle itself that connects the two hubs together. And we don't have that anymore. That's been eliminated, so that's why this cross member is so important. And they run through basically how everything should be welded on, and you've got full welds, and you can leave, there's certain places that gaps need to be left and stuff. But again, you can read all about that. And I'll be covering this a lot more when we actually do the physical installation of this kit on the new chassis. There's a step-by-step assembly guide which runs through, the various logical processes for bolting all the bits and pieces onto your trailer once you've done all the welding. And the beauty of this particular system, which I thought was really good, is it has a wheel alignment feature, so you can actually adjust toe of the wheel. See if we've got a drawing with a wheel on it. I don't think we have, actually. Maybe on the next one. Let's have a look. Oh, yeah, you can see it with the hub here. So down here we've got the brake drum, because it's drum brakes on this system, and this would be the rear of the trailer. This is the front of the trailer. They are up front, and you can adjust that wheel whether it tows in or tows out. Personally, on my trailers, I like zero toe. I like both wheels to be parallel to each other, but in some countries they do like to put a bit of toe in. But the more toe that you have, the more tire scrub you're going to get, and the greater the rolling resistance as well, so you can use more fuel. So zero toe, in my opinion, is the best option, and it's good that we can actually there is some adjustment for that once the kit's all fitted, because it does allow for any minor imperfections in alignment of the actual module to the chassis. Not that there should be any, but it allows for it. This is just an exploded diagram of all the various components, and you can buy all the bits independently, or individually. So if you have any, servicing work to do in the future, that's really good to know. It's quite reassuring because, again, you want to be buying a kit that you can get spare parts for. And finally, you've got the kit configurations. That's not really relative to us at the moment, but again, it could be quite useful in the future for you. So again, I'll include that, as a file in that folder. Right, back to the bench. Let's go and watch a video. So Cruisemaster also produced the hitch to go on the front of the trailer to connect it to the towing vehicle, and their hitch utilizes because it's got electric brakes on the trailer. We don't need to worry about any kind of hydraulic system around the hitch area. It does simplify the whole system tremendously well. I found a photo of the hitch that's coming with the kit. But they do various sizes. I think they go up to like 6.5 ton for big trucks. That's like an eyelet one, very different, and a 4.5 ton hitch as well. So there's quite a few out there to go at. I'm still learning a lot about this particular product. It's something which has only recently been brought into New Zealand in the last few months. Even the distributors learning themselves about all the stuff that's available from Cruisemaster over in Australia. And this is going to be a fantastic test for this new equipment on the trailer that we use for this adventure trip from Cape Reinga all the way down to Bluff via gravel and off-road. It's going to really put the kit to a good test, and we'll be able to give you some excellent feedback on how well it performs. Who knows? Right, this is a photo of the hitch itself, and then we'll talk about that. Now, there aren't too many photos on this particular website. This is the actual official Cruisemaster website. If you want to go onto there, it's cruisemaster.com.au, and there's lots and lots of information and some really good videos on there. I'm not going to bore you with all of those. The important thing is that you can go onto the website directly and check out what's relevant to you. This is the 3.5 ton hitch. I heard on the grapevine they made a 2 ton hitch as well, but I'm not entirely sure, and I can't find that on their website at the moment. But this is the one with the hand brake, which operates a physical brake cable, a pull cable, to activate the hand brake as part of the brake drums mechanism, or the assembly. But it attaches to the vehicle. You actually remove the 50mm ball and you attach this coupling here instead. So this particular system does not use a standard 50mm ball, which it's not the end of the world. But it does mean if you want to swap the trailer from one vehicle to another, you've got to swap the hitch. You've got to swap the actual coupling across as well. The actual, what would be the tow ball, has to come off, and you'd fit that, which, you know, adds a little bit of complexity, but it's obviously there for a reason. But it does look a very substantial piece of kit. If we end up getting the 3.5 ton one, it's going to be way over the top for this little trailer. The trailer should weigh about, I reckon, about 1,000 kgs, maybe 1,200 kgs fully loaded. So this is going to be, you know, massively over-engineered for our particular job. So I was very pleased when Cruisemaster, you know, or should I say the agent in Auckland, you know, Trojan, or they're the importers of Trojan, Trailcom. The lads down there, you know, made me aware that this new system is available, and there are other similar systems on the market as well, which are independent, coil sprung with shock absorbers and so on. But this is the one that is available right now for me, and I'm very much against the clock getting this trailer made in time for the trip. It's going to be a lot of work in a short period of time. So when you're thinking about a trailer, before you even start to design the chassis, you've got to decide what kind of suspension system you want. Is it going to be in suspension units with the rubber blocks, you know, the rubber triangles inside the inserts inside the box section? Very sort of maintenance free. They last for years. I built a big 4-ton plant trailer about 20 years ago, and those in suspension units are still working fine. You know, they very rarely need any kind of additional work. You can send them off often and get them serviced if need be, and they'll put new rubber inserts in there and send them back to you and charge you probably quite a lot of money for it. You could use leaf springs, and leaf springs are, you know, readily available all over New Zealand. So if we were to break one on the trail, and this was my sort of train of thought, that I could get one locally, pretty easy to fit, not too hard to fit, and get you back on the road again. But we couldn't get the hubs, the hub stub kit to work with that, and the in-suspension units were way too expensive. So this, although this is expensive, they can drill the drums to suit the PCD of the little Jimny that we're driving, that we would turn the trailer with, which means we only need to take one spare wheel, not two. So that, again, that cuts down on load. We could take two if we want to, but then we've got two spares that could be used either on the trailer or on the Jimny. It gives you better versatility. So that was my train of thought there. Once you've decided on your type of suspension, making sure that you can get the hubs with the right PCD for the wheels that you want to use, if you are wheel specific. If you're not too fussed, then that's not really a factor for you, is it? But once you've decided on that, then you can start with your trailer design. And I'm going to rewind the clock now, right back to before I started doing the research, and just the sort of fag packet design of what the trailer was going to look like, the chassis. And originally, this pod was going to form an integral part of the chassis. It was going to be basically welded to the chassis and provide additional structural strength to the chassis itself over the suspension area. That's no longer the case, because we have to use the large box section to support the CRS system. Right, say goodbye to the CAD drawings and prepare yourself for Andy's fag packet design scribbles. Here we go. So this drawing was done right at the start, just to give me, you know, a rough idea of probably the best way forward. And on the trailer, we've got part of the design brief was an adjustable length hitch, which is really important when you're driving or taking the trailer off-road. You want a really long hitch area to make sure that there's a good gap between the back of your towing vehicle and the obstructions on the trailer, whether it's a box or a motorcycle, whatever it is. If that gap's too small, then when you're going through a ditch, then whatever's on the trailer could actually start to make contact with the back of the vehicle. That's bad, it's going to cause damage. But also the longer hitch, and I've designed mine so that the trailer can go a full 90 degrees. This is the tow ball here, look. It can go a full 90 degrees to the back of the towing vehicle without making contact. Essentially, the towing vehicle sort of finishes around about, you know, when it's in full lock, the towing vehicle's around about this sort of area here. So even a motorcycle on the rack, this is the cross rack for the Honda monkey bike, wouldn't make contact with the little Jimny. So with it being adjustable, when you're using the trailer on the road or you're going to go onto a ferry and you pay by the length of meterage length of the trailer, you can shorten it down and save yourself some money. Basically, get it within the standard length of trailers, so you're not paying a premium. That was the plan behind that, and to facilitate that, we were going to use two different size box sections. This was going to be 100 by 100 by 4mm wall box section, and this was going to run the full length of the chassis, basically like a central spine, and that will provide the main structure of the trailer. Remember, the pod was welded at this point in time, was welded to the trailer. And then the piece that slides in and out inside that box section to give you that variable length of hitch was 89mm by 89mm box, 5mm wall, and it'd be double pinned. There'd be 2 pins going through there for security, which would then either hold it in the short position or the long position, depending on what you were doing. Now you can see here on the drawing, because we have the central spine, we would then have just some box section running around the outside with some cross pieces. The springs would mount to the outer pieces here, look. Because the pod was integral, that would provide the rigidity between the central spine out to the outer edges. So we wouldn't need big heavy cross members. It was just central spine with some outriggers on it. Super lightweight and exactly what I wanted for this particular project. And you can see here a side elevation of the same. You've got the leaf springs down the bottom. You've got, on this particular drawing, the box section doesn't run all the way to the rear. The second generation of the design, it did, and that would then allow us to have a really good, strong recovery point at the back of the trailer, which, if we had to pull the vehicle and the trailer back together, it would help to transfer that pulling force directly back to the hitch on the towing vehicle, so it wouldn't put too much stress within the trailer chassis itself. The last thing you want to do is pull the back of your trailer off, right? This is the pod. This is all covered, obviously, with the aluminium sheeting, and this is when I decided to put that kick at the back of the trailer to improve departure angle, to cut that whole corner off there, look. And on top, we're going to mount a roof tent. So I was pretty critical that the top of the roof tent height was certainly no higher than the roof of the towing vehicle to help with aerodynamics and so on. And of course, stability. You don't want too much weight up high when you're using the trailer off-road. Again, you can see here the side elevation of the bike mount. This is the kick up for the front wheel, and the 2 pinholes for the adjustable drawbar. Again, dimensions have changed. Back then it was 65 by 65 5mm box. It's now 89 by 89mm 5mm box for the final piece. One of the advantages of using the electric brakes on this design is the electric brakes work through the normal wiring of the trailer. Basically, they just sense when the brake pedal is pressed and the brakes are activated. If this was hydraulic, then we'd have to have a flexible hydraulic hose to allow for that change in distance between the hitch and the calipers when the drawbar is extended or put back to the short position. With it being a wire, a standard coiled electrical 7-core cable will accommodate that very, very easily. It'll be a far better setup, a lot tidier as well with the electric brakes. So that was actually a bonus going for that particular system. Now, where's my next drawing? This is an old one as well, actually. So you can see here, look, the central spine, the hitch, adjustable hitch at this end. This is a really quick and dirty drawing. You've got the bike rack at the front, and then you've got those various outriggers running across. Again, another idea. This is just a cutting list that I did on the side for that pod. Now, where do we go next? Okay. So on this particular drawing here, I know it's going to be reasonably hard to follow. I hope you can sort of muddle your way through this, because these are just my scribbles. I tend to draw things in my own way. I was starting now to come up with a new chassis design to incorporate the CRS, the independent coil sprung suspension, from Cruisemaster, and because they require that that chassis arrangement, that really thick box section. See if I can find the drawing for you again. Here we go. Right, because they require this kind of arrangement to help, you know, provide the support that these in-suspension units needed, I had to transpose that and the dimensions onto, you know, sort of my trailer chassis overall. And this was sort of the first drawing to do that. So originally I was going to put the rear cross member right at the back of the trailer, and we've got here the front cross member here, but this essentially was completely wrong, and I had to redraw it. Incidentally, the area for the motorcycle rack across the front, I've allowed 800 millimeters for that, and that's the width. That's about, I don't know, about 10 millimeters. Sorry, about 100 millimeters longer than the bar width of the actual bike itself. So there's a bit of room for movement and clearance. So the final drawing I came up with, and this probably won't be the final drawing, is I had to work out exactly where the two heavy-duty cross members were going to be. And I've decided now to make the outer chassis rails, because obviously the area between the in-suspension unit here and the rear one, both of those had to be 100x50 box, as do this section of the chassis rail. So I decided to make the whole chassis rails, the outer rails, all the way down here out of 100x50 on both sides, obviously, and both of these two cross members again will be 100x50, 4mm thick box section. And then just to run the actual, you know, the original plan was to run the spine all the way through the chassis, and I may well still do that, but it will be welded onto the back side of this. I don't want to cut that and have those welded either side of the box, because that will actually greatly weaken the effectiveness of that that cross member, because, you know, the sides of this box section could start to bend a little bit and it'll all go out of alignment under extreme stress situations. So to meet Cruisemaster's design requirements, this cross member must go all the way across in one complete unit. It can't be broken anywhere, there can't be any welds on it, it's got to be one piece of steel. So the spine will run to that, and then potentially the spine will then continue further back, and that would then pass any kind of recovery load at the rear of the trailer. So if you've got a tow rope on the back, it's going to pass that through the whole trailer onto the towing vehicle without any kind of stress with any of the components that make up the chassis. That's the plan. Now there's quite a long distance here, so there'll be an additional cross member here, which is just 40x40 box, and as per their suggestion, there should be some bracing here and here as well. This is where the independent suspension units are mounted, in this area here and this area here. The actual wheel, the sort of the axle point where the wheel is 312 millimeters behind the pivot point. So the actual wheels are here. So on this particular trailer, the wheels are quite far back on the chassis. However, most of the time the motorcycle won't be on the trailer, so I had to obviously, you know, look at the fixed weight of the trailer and where the load is. If I put the wheels too far forward, then there'd be a negative hitch weight, and when the bike's off, it would be pulling up on the tow hitch, which is a very bad thing when you're towing a trailer. There should always be some hitch weight, ideally about 100 kgs normally, and that way the trailer tows a lot better. So that the design accommodates that as well. And I've pulled forward the rear cross member by about, I think about 900, that's right, 900 millimeters from the point where it starts to fold in here, look, to come in to form the A-frame. And one last point on trailer design that I wanted to bring in, and I'm by no means am I an expert in trailer design, but, you know, I've learned a bit over the years, is this central drawbar here. It's very important that it's supported properly. You know, we've got, you know, could you imagine if these bits didn't exist, right? If these pieces didn't exist, we didn't bother with that, and it was just welded straight to here, so you'd have no additional bracing. The loading in that area there is phenomenal. So that's now being supported by the fact that that extends right through to the first heavy cross member, so it's got good support there. It's got an additional cross member here, and of course it's got the cross members coming down the out, so the A-frame piece is coming down here as well. So there is no way that would bend. It's got, 3 points of extreme strength around that area there. And that's important again for an off-road trailer, because again there's a lot of stress, a lot more stress put on a trailer used for off-road than there ever is on the road. So this video, we haven't even turned a wrench or a spanner in this video, which is most strange for my YouTube channel. But this video is intended to be an introduction into looking at different types of suspension units for your trailer. It's only a very brief overview. It ideally is a catalyst just to try and trigger a few thought processes for the viewer, so you can go off and do your own research. But you've got the in-suspension units, the rubberized type suspension, you've got the traditional coil spring suspension, and then of course you've got this much more modern and much better suited kind of suspension, especially for off-road type use trailers. And then we've also got different kinds of brakes. Do we bother with brakes? Do we really need brakes? In an off-road environment, you absolutely do need brakes. If you're going down a hill and it's quite loose terrain, and you're braking as you're going down, or even using engine braking. Remember, the trailer's not being braked at all and it's pushing that vehicle down the hill. Often it can cause the towing vehicle to be pushed out sideways, and that would cause the vehicle to jackknife. Really bad situation, potentially roll over or instigate a rollover situation on a descent. If the trailer's got brakes, then that's fantastic. The brakes are being applied on the trailer, and that's helping to keep the whole vehicle in alignment in the straight ahead position and much more under control. However, with a hydraulic brake system, yes, you've got brake assistance going downhill, that's great. What happens when you're going up a hill and you fail to get to the top of the hill, what we call a failed ascent? Well, with hydraulic brakes or traditional cable activated drum brakes, even like on the Ifor Williams trailers that we have, when you're on a hill parked uphill stationary, the brakes on the trailer are not activated. They're not doing anything at all. Essentially it's unbraked. You try and reverse back down that hill, the only brakes that you've got are on your towing vehicle, and often your front wheels will lock up because they're a much more powerful brake system than on the rear of your towing vehicle. About 70% of the braking force is on the front axle. So when those wheels lock up, you lose your steering. So you've got a major problem trying to reverse down a hill with essentially an unbraked trailer in an off-road environment where you've got very, very little grip indeed. Tarmac, okay, you can probably get away with it, but on loose gravel, you're going to be sliding down that hill. Very difficult to control the trailer and keep it in a straight line because you're losing your steering. It's like a compromise between trying to brake and slow the vehicle down, but also maintain some kind of steering. With the electric brake system, and I've never really been a fan of electric brakes, but in an off-road environment it really does start to make sense because it's activated by you pressing the brake pedal and not by the coupling being compressed under braking force like with a hydraulic or a cable operated brake system, which means you've also got trailer braking when reversing down an ascent, and that could make all the difference between you getting to the bottom of the hill safely and ending up in a big heap at the bottom. So again, do consider that. I'm not a fan of electric brakes, but I think under these circumstances it could actually be a really good idea. One of the other really good benefits of electric brake systems is you have an adjuster where you can actually adjust how much braking force is being applied by the trailer brakes when you apply the brake of the towing vehicle. You don't get that facility on cable operated brakes or hydraulically operated brakes. It sort of happens automatically. If you brake really, really hard, it pushes the plunger a lot more on the coupling, and that applies a greater pressure into the brake system on a hydraulic system. On a cable operated system, yes, you brake harder, it pulls the cable tighter or with more force, and it applies greater force on the drums, on the drum brakes. But you can't adjust it depending on the terrain type. So again, in an off-road environment, you might want to back off the brake assistance a little bit, or the amount that the brakes have been applied on the trailer, and you can dial it off very simply by a little controller. On dry tarmac, you might be going down a very steep tarmac hill, and you can crank up the brakes so you get maximum braking from the trailer. You don't want the wheels locking up like it would do if it was on maximum on a loose surface. because a locked up wheel isn't really providing much of a braking force at all. Defeats the object. Okay, so I've got a lot of work ahead of me. Hopefully this video stimulated a few thought processes and ideas around trailer design. There will be videos covering the actual chassis build and the fitment of the CRS2 system onto the trailer. So that's going to give you a really good insight on all the measurements that need to be taken. We'll be doing an overview of all that in the video, and just how strong that chassis needs to be, even for a lightweight trailer like ours. Okay, crew, well, that brings us to the end of this video. It's been nothing but a talky bit, but it's there to stimulate your mind towards trailer design, but also to introduce forthcoming videos on that installation. Okay, well, you'll find me, thanks for watching. If you haven't subscribed yet, why not subscribe to the channel? You'll find me on Facebook, Instagram and Twitter. Communicate through those or through a direct email. My email address is down in the description. You can tell I haven't done a video for a while, can't you? You can also support the channel. That's through Patreon or PayPal. We are going through a major build at the moment. Mrs. Mechanic's doing a bike ride from Cape Reinga all the way down to Bluff on a little Honda monkey bike. This is going to be the trailer for the support vehicle, carrying all the gear for that particular trip. It's not a tarmac road trip by any means. This is off-road, gravel roads, river crossings, all sorts of stuff. So we need to take some gear with us to make sure that she can keep on the road, or on the off-road, so to speak. If you want to support the channel, you can do that through Patreon. Any donations that come through will be going directly towards this build and paying for that trip. It is being done for charity. Any donations that are made through the Make-A-Wish page that Mrs. Mechanics set up, and I'll put a link in the description. Any donations through that are going through to the Alzheimer's Trust. All right, crew, the trip is due to commence early March 2023, which is only a few weeks away, and we'll be away for nearly a month doing that epic adventure. And it'll all be filmed, so you can see what's going on when it hits the channel. All right, crew, thanks again for watching. Cheers, over and out.
And you get the flip up again.
Oh,